In section 14, we're going to be continuing our study of polynomials by looking more at graphs of polynomials. Now we'll get to graphs of polynomials toward the end of the section, but there are several little things that we need to be able to accomplish in order to get the graph of a polynomial completed with any level of accuracy. So the kind of things that we're going to need to be able to find from the function equation is x-intercepts, we will also need the y-intercept, and we'll need something else called the end behavior. So we're going to spend the first part of this section, in fact the majority of this section, talking about the x-intercepts. And the x-intercepts is a much bigger concept called the zero. The zero is defined by the following. It says let f be a function and let c be an element of, and then we have a new symbol here which is this double bar c. The double bar c is the set of all complex numbers. So right now we understand that there are real numbers, and the symbol we use to represent all real numbers is the double bar r. Now real numbers includes rational, and it also includes irrational. So once we put all the rational and irrational numbers together into one set, that's what we've been calling the real numbers. So the complex numbers are sort of the same idea. The complex numbers include all real numbers and all imaginary numbers. So anytime that we've come across the square root of a negative, we've been saying that that is non-real. Well, today that is going to change because we're going to be talking about imaginary things in this section. So that's what capital C, the double bar C, represents. It's the set of all real numbers and imaginary numbers all put together into one set. These are called complex numbers. So if f of c is equal to 0, so if we have some number that we can substitute into the function and the answer ends up being 0, then that number that we plugged in is called a zero of that function. So some things that are worth mentioning about the zeros. The zeros of f are the solutions of the polynomial equation f of x equals 0. So anytime we've ever wanted to calculate the x-intercepts, to calculate the x-intercepts we would always let f of x be equal to 0. So when we were doing that, we were actually calculating zeros, and then you would take those x values and you would write them as ordered pair. So we are now allowing ourselves to have the possibility that your zeros could be imaginary. Now, if they're not imaginary and they're real, then that's what the second statement says. If your number is actually a real number, then you can take that number and you can write it as an ordered pair. And that ordered pair represents the x-intercept. So that's where we're going to be going with this. We're going to be learning about zeros, and any of the zeros that are real are going to get to qualify as being an x-intercept. Anything that's imaginary or complex, we are not going to worry about trying to graph those because they don't fit on the real number line that we use here in class.